Hello, Algebra 1 students, and welcome to Lesson 2 of Topic 1. The title here is Solving Linear Equations. I believe that all of you have very much prior knowledge and experience of solving linear equations. Now, again, just to refresh yourself, the reason we call these linear equations is because there's usually an x involved, and it's to the first power. Now, remember, you don't see that first power, but that's why it's linear. Okay, so let's just go ahead and do some today here and get you refreshed. I know summer was a long time, right? All right, so solve linear equations. What is the value of x in the equation? 2 times the quantity of x plus 4, all divided by 3, minus 8 equals 32. Okay. Now, typically, when I look at an equation, I ask myself, what is happening to the x? So if I'm looking at this, okay, so the x is being added to 4 inside the parentheses. So this is what's happening, added by 4. Then it's being multiplied by 2. Then it's being divided by 3. Then you're subtracting 8 from it, right? So first thing, second thing, third thing, fourth thing. So typically we go in reverse order, right? We use what are called inverse operations, and we go in a reverse order to solve for x. So the first thing I would do here is I would add 8 to both sides. So this nasty looking fraction stays the same. 2 parentheses x over 4 divided by 3 equals, and when I add 8 to 32, I get 40. Okay, check. Now we're going to get rid of the dividing by 3. How do you get rid of dividing by 3? Well, you multiply both sides by 3. That's the inverse of division. So multiply both sides by 3. So the 3's cancel. This 2 times x plus 4 comes down. The right side, you actually multiply 40 times 3. 4 times 3 is 12, and then add the 0. So there's that done. Okay, next we have to get rid of this 2. Now we could do two things. We could divide both sides by 2, which is typically what you don't do. You've been taught, if you have a number outside the parentheses, you do this thing called distribution. So that's what we'll do. We're going to distribute. So when we distribute, we're going to multiply 2 times x. 2 times x is 2x. We're going to multiply 2 times positive 4. 2 times positive 4 is positive 8. That equals 120. So now notice here, right? So notice now the equation's kind of changed. Now what's happening to the x is we're multiplying by 2. So let me change colors. Now we're multiplying by 2. That's the first thing. And then we're adding 8. So now we're going to do this in reverse order. So now we're going to subtract 8 from both sides. 2x equals 120 minus 8 is 112. And now we're going to divide by 2. Right, so subtracting 8 gets rid of that 8. Dividing by 2 now gets rid of that times by 2. And your x value is 56. And there we go. Okay, so again, if you have trouble solving linear equations, you ask yourself, what is happening to that x? And you undo those things in reverse order. All right, next we have a word problem here. It says solve consecutive integer problems. The sum of 3 consecutive integers is 132. What are the 3 integers? Okay, well, first of all, I see this word sum, right? When you see the word sum, you should be thinking of addition. So we're going to add some numbers. And now we want to find 3 consecutive integers whose sum is 132. So sure, you could take forever and a day to just guess. All right, maybe 30, 31, 32, right? We have this, so consecutive, right? Maybe it's, 25, 26, 27. I don't know, but we can use algebra, right? Let's let the first integer be x, okay? Well, then what would the next consecutive integer have to be? Well, you would just add 1 to x plus 1. What would the next integer after that be? Well, it would be x plus 1 plus another 1. But we're not going to write like that. That's silly. We're going to add the 1 and 1 and get x plus 2. And there's our 3 integers. Their sum is 132. So watch what I do. X plus sum, x plus 1, plus sum, x plus 2, equals 132. And there's your equation, right? So we can make, instead of doing guess and check, which is, investigative work is great, right? When you're a younger student and you don't have these, what do I call them? Sophisticated methods to doing problems. Yes, guess and check is great. But as you get older, guess and check would take you forever. So Building equations, creating models is good. All right, let's combine our like terms. Now, this is different than the last problem. Here on the left side of the equation, you have 1, 2, 3, 4, 5 things, an x, a 1, an x, and a 2. Over here on the right side, you just have the 132, so that's not going to change. But now over here, we can combine this x, and this x. This is a 1x plus a 1x plus a 1x. That's 1, 2, that's 3 x's. And now we're going to combine our constants, or our numbers without variables, plus 1 and plus 2, that's plus 3. Okay, and now again, we ask yourself, what is happening to the x? Well, it's being multiplied by 3 and added to 3. So let's get rid of the adding to 3 by subtracting 3. So the 3x comes down. 132 minus 3 is 129. And then we divide by 3. X equals 3 goes into 12 4 times, 3 goes into 9 3 times, and there is the first integer, 43. So your 3 consecutive integers are 43, 44, and 45. And again, if you do a quick check, right, 43 and 44 is 87. Add that to 45, that is going to be 132. Quick check. We're good. All right, nice. Okay, I got one more question before our break. Okay, example 3, use linear equations to solve mixture problems. Ooh, it says a lab technician needs 25 liters of a solution that is 15% acid for a certain experiment. But she has only a solution that is 10% acid and a solution that is 30% acid. How many liters of the 10% and the 30% solutions should she mix to get what she needs? Okay, so the idea is that, hey, we need this certain percentage of acid. Well, we don't have that exactly. We can't just do it directly. We have to use these two other percentages to kind of mix them and get the 15%. So if we look here, this is what we want our total mixture to be, 25 liters of 15% acid. Okay, now we have two types of acids to use, a 10% and a 30%. And we want to know how many liters of each we would have to use to combine them and get to 25 liters of a 15% solution. So the idea here is, okay, I'm going to take 10% as a decimal, right? So 0.10. I'm going to multiply it by some number of liters. I'm going to add that to 0.30, the 30%, times another number of liters, and that needs to get me a 15% mixture of 25 liters. Okay, so we're going to let X be this guy, this first question mark, a number of liters of 10%. So the liters of 10%. So then what is the other one going to be? Well, if your total is going to be 25 liters and you're going to have an X of the 10%, then you need 25 minus X of the 30%. You don't want to introduce like a Y. You don't want to do that because you only have one equation. And we'll talk later on in this course that, if you only have one equation, you can only have one variable to solve for. Okay, so now we're just going to do a substitution. I'll use blue. We're going to put this X here. We're going to put the 25 minus X here, and we're going to solve this. So I'm going to drop the zeros in front. So 0.10 times X plus 0.30 times 25 minus X, sorry about that, equals 0.15 times 25. Okay, so this is just 0.10x. We need to distribute the positive 0.30. So 0.30 times 25 is 0.75. 0.30 times negative x is negative 0.30x. And then over there, 0.15 times 25 is 3.75. Okay, on this left-hand side, I have a pair of like terms, the 0.10x and the minus 0.30x. So combine them as they are. That's a minus 0.20x. Bring down the positive 0.75. We're going to subtract the 0.75 from both sides. I'm going to bring it up here. So the negative 0.20x remains. The 0.75s cancel. And on the right-hand side, 3.75 minus 0.75 is 3. And now what we're going to do is we're going to divide both sides by this negative 0.20. When you divide 3 by negative 0.20, you get 15. So x equals negative 15. Okay, so I made my first error of the year. Again, more to come, right? So I could not read my writing, right? 0.30 times 25 is 7.5. So I'm going to change it in red so you can see what I'm doing, right? Change it in red. I don't want to confuse you, right? That'd be bad, right? Okay, so I'll put it in red. So this 0.30 times 25 is 7.5. So this should be plus 7.5. We're going to subtract 7.5 from both sides to get negative 3.75. I was confused here because I should not have got a negative number. And now we're going to divide both sides by negative 0.20 so that the negatives cancel. And 3.75 divided by 0.2 is going to be 18.75. So sorry about that. Again, we all make mistakes, right? The good thing is I caught it. And you know why I caught it? I knew that this could not be a negative number. It cannot be negative, right? So negative, no. So that's why I stopped and checked. So what this means is if there's 18.75 of the 10%, then we have to do 25 minus 18.75 to get the amount of the 30%. And 25 minus 18.75 is 6.25. So our answer is 18.75 liters of the 10% and 6.25 liters of the 30%. And there we go. Good deal. All right, so that was video 1. Video 2 is coming right up.